This lesson we're looking at area between curves. So essentially, we're focusing on the process that we'll have to cover in order to calculate an area between curves. But we'll start by simply visualizing the physical area between two curves. So if we set this up, we have a Cartesian plane with two functions. So function 1 is f of x, and function 2 is g of x. Now, when we're looking for area bound between two curves, the important factors are obviously the intersect points. So if we look at the intersection points as A, as B, and as C, these 3 points, the points of intersection, will determine when the difference between the two functions is 0. So that's when it changes from a positively signed area to a negatively signed area. So in this situation, what we're looking at when we're finding the area between curves is the area between function 1 and function 2, or g of x and f of x. We could continue that on. It all depends on the bounds and the statement of the question asked. Before we look at area bound, generally in this situation we have to consider a difference function. So that is that we look at the difference function d as one function subtract the other. So if I'm going to say that it's g of x subtract f of x, then when g is above x, it will be a positively signed area, so positive area. When then f is greater than g, it will be a negatively signed area. And at this point beforehand, this will be a negative area, and this will be a positive area, as g of x is greater than f of x. Hopefully that makes sense. When we're using this difference function, we don't have to worry about whether it crosses the x-axis or not. We're just looking at the difference between these two functions. So if I wanted to say that the area bound by these two functions, if I wanted to calculate the area bound by the two functions, I would say area is the integral of our difference function with respect to x between a and b. As that's a positive area, it will just be b and a. And then we're looking at the integral of the difference function with respect to x for this second section. As that's a negative area, we will flip the limits. So we'll say that instead of being between c and b, it will be between b and c. And that is our area bound by the curves. So that's going to be our approach when we're looking at area between curves. It's always best to start by visualizing it. So draw a sketch, identify the areas, and determine whether they're positive or negative. So when we start looking at the idea of the difference function and signed area between curves, there's two approaches that we can take. So let's now define two functions. Let's say that my first function is f of x is equal to x cubed take x take 1, and my second function, g of x, is going to be x squared plus 2x take 3. So two polynomial functions. When we want to think about the difference function, we're going to subtract one from the other, but the first thing we should do is we should draw a sketch of it. So we're going to use our graphics calculator to draw a sketch. So menu, graph, and we put in our two equations. Okay, so you can see here that the cubic function looks like that. And then we've got our quadratic function that crosses through down here, back through and up. So we've got our two functions. The area between these curves can be broken down by the intersection points. So A and B, and we've got this third point here, which is C. And the area between the two curves will be here and here, and if we set another limit, it could continue beyond as well. So we want to find that difference function, and it doesn't matter which way we do it. So if we say d of x is equal to f of x take g of x, so this blue one here is f of x, and the green one here is g of x. When f of x is above g of x, it will be a positive area, and when it's below, it will be negative. So there's two ways we can visualize it. We can visualize it just like that, and we can look at identifying those areas going, this is positive, this is negative, and determining our function. So we could easily say here that area is between b and a, the difference function dx, and instead of between b and c, we flip those, and it'll be bc d of x dx. So we get our positive, and we've flipped the limits on the second one to make it positive. We could also look at this in a slightly different way. So we could sketch this again, looking at a sketch of the difference function. Now, of course, this takes a little bit longer, and it can be slightly confusing, so you don't have to take this approach. But here, if I go into vars and graph, then I can say, because I've gone f of x take g of x, I can say y1 subtract y2. And I'll turn the other two off so we don't get distracted by them. So deselect and deselect. Now I can graph. So you can see here that we get a single function, and we've got our positive area, and we've got our negative area, and these intersection points A, B, and C will be the same. So we can either work with the true sketch of the two functions, or we can sketch the difference function, which is what we define it as, f of x take away g of x in this case. And it will have the same intersects, this time as roots rather than intersections of two functions. And the areas between each of those intersects will be equivalent as well. So two different ways to see the same thing, and then it can come down to a decision with your approach. Okay, so after all of that, our focus is to calculate the area between the curves, and depending on how it is defined, it'll be slightly different. But generally what we're looking at, and we'll solve this question for real now. So if we go back, I'm going to use not the difference function, but the other two functions, and I'll select, and we can draw. First of all, we'll need our intersection points. So x-intercepts will be, we'll go g-solve and intersect, so that's f5. We've got negative 1.62. And we go across, and we've got 0.62. And we go across, and we've got 2. So check those, 0.62 and 1.62. It's all approximately in this case. If I was finding the area would be the integral between 0.62 and negative 1.62 of our difference function with respect to x, and then the integral between 0.62 and 2 of our difference function with respect to x. A difference function, as we said, it will be f of x take g of x, would be x cubed take x take 1, subtract x squared plus 2x take 3. And so we'd end up with a difference function of x cubed take x squared take 3x plus 2. That's a difference function, so we'd be finding the integral between these limits of that difference function. Now to calculate this quickly on our graphics calculator is really quite easy. So we go to F5 G-solve, so F5, and we go F6 to go across, and then F3 for the integral. Now we want to use the intersection points, so we hit F3 for intersection, and so we'll use this first intersection. We'll go across, and the second intersection, And you can see we've got two answers there. We have a straight integral, which is what we don't want, and we have an area, which is 5.95 units squared. Now, if we did that again, and we look at the integral using the intersect of just the first section, we can see that this area and the integral is the same, 4.65. And if we go G solve integral and intersection again, and we just look at the second area, we can see that it's a negative section 1.28 and the area is 1.28. Okay, so hopefully that makes sense. That's our focus and our approach with difference functions. The goal is to find physical area, and using our graphic calculator or calculating by hand, we need to be able to perform these processes. So make sure you understand how to find a difference function, whether an area is signed positive or negative, and then how we combine those areas to be able to determine total physical area. Okay, thank you for listening.